regeneration makeup water. So we start with the river water pump house. You got a river out there, and you have a filter that sticks out into the river. You've got the sides is a cylinder, and the sides of the cylinder are the strainer basket, and the ends are just plugs. And the water is forced to go around it, and then the water, by gravity, goes through that strainer and into the pump house. And then we've got two pumps. Each pump is 5,000 gallons a minute. Go to the common header. There's check valves too, aren't there? Go ahead and draw some. There's probably some, right? And then there's a flow transmitter. And then there are recirc valves. Just go back down into the caisson. We know the bow ties are valves. When I put a little square on the stem, that's a motor operator. All right, what else do we have out there? There's seal water. So coming off the service water header, that goes to two booster pumps. And then there is another leg that just goes around the booster pumps. This goes to a solenoid valve, which puts seal water at the pumps. Pressure transmitter on the upstream side. This pressure transmitter, when it falls, I want to say below 100 psi, then it says, hey, you're not going to have enough pressure, so it kicks on the booster pumps and picks up the pressure. At the seals, there's like a little flow switch. I don't have a symbol for flow switch. And there's a local pressure gauge. This is the only pressure transmitter on the entire surface water system. So normally out there you see 120 pounds. When you get a pump start, first thing that happens is the solenoid comes open, puts seal water on there. That causes pressure to dip. And then the service water pumps adjust themselves, and that pulls the pressure back up to normal. But during that dip, usually you'll see these booster pumps, one of the booster pumps kick on. So you call Danny Rhodes, say, give me a pump start. He says, here comes your start. You should get seal water. You will probably get a booster pump start. Then I think one of the recirc valves has to be open. One of them is almost always open now. They kind of changed the way the logic works out there, and I'm not 100% certain on how everything works. And then,
It's left in local.
say it again?
It's left in local.
One of them's left in local, and it doesn't matter, they're
You
not,
try to put it in remote, it'll go back and shut.
but instead of being Alpha Bravo, gotta shut one, they're not specific to a
Right,
river water pump now.
It used to be that even though these things were coming off one header and then going to the same place, that the alpha pump wanted to see the alpha recirc valve open, and they fixed that. But if one of them's always in local, then it's not fixed. It's just going to sit there and be open all the time. And I guess as long as it sees it open, you get your start permit, so everything's fine. You get about 2,000 gallons a minute recircling through this. Somewhere around 1,500 gallons a minute or less is the minimum flow on these pumps, and they start cavitating, and then they trip on low flow. And honestly, if you were to put one into auto right now and everything was working perfectly, it should go shut. Because we've got 7,000 gallons going out to the clarifiers, maybe less, but somewhere in that ballpark, depending on load. And then you only need 4,000 in the logic for 2 pumps to run. So that guy goes, hey, we got more than 4,000, I should go shut. But if it doesn't come back open again, then we're screwed. So I think right now we still have one of those pumps in hand, don't we? From our freezing night fiasco excitement a couple weeks back.
Oh, river water pump.
River water.
I don't know if they ever fixed that or not.
Me neither. All right.
Probably still in hand, if y'all had to put it in hand,
We started
yeah, it's probably still in.
All right. So then, oh. So you've got an air compressor, and then that goes to a vessel. Does everybody work for that vessel? Reservoir. Reservoir sounds like it goes for water. I don't know. And then a solenoid valve on that, and then that goes out to the screen. And then once a day, you're supposed to go and look out at the river and make sure there's not somebody where it's going to blow up, and then flip the switch, and then that blows the air, and then that knocks all the sticks off this, and then they flow off down the river. And as these pumps run, they pull water out, so this level goes down, and then the level in the river is higher than the level in the caisson, so the water going in makes up for it. All right. So the river water goes out, goes over the levee, and there's a vacuum breaker there, and then we got a chemical building. We got 2 tanks, and one is hypo, and one is coagulant. What is the purpose of hypo? Kill the growies. Eliminate biological fouling. What is coagulant?
Makes the dirt and stuff clump together.
There you go. So coagulant is like a thick, snotty sludge. And the dirt and stuff in the water sticks to the sludge and makes bigger clumps. And then we're going to the clarifiers. We got flow control valve. So you got 3 chambers. You got your fast mixer, and then your reaction mixer, and then you've got your rake. So this muddy Mississippi water goes into the reaction mixer, and it has to go down and under a wall, and then goes to the rapid mixer, goes under a wall, goes into the normal mixer, goes over a wall, and then it flows up through the clarifier. And you got all those plates. You got little holes on plates, and then the clean water comes out. And then the sludge settles down. The rake is just supposed to keep the stuff on the bottom from settling and becoming a rock. So what this is doing is it's like you've got a mason jar and you scoop up a bunch of Mississippi River water and you just leave it on the table, and then just gravity does its thing, and all the stuff settles at the bottom, and then you suck off the top where the water's clean. But it's doing it at 5,000 gallons a minute. And the way you've got to do that, to let that gravity thing work, is you've got to slow down the water. So you take the water from a pipe that's this big and put it in a pipe that is the size of the clarifier going up, right? So it's like a pipe the size of this room. So in terms of gallons per minute, 5,000 gallons a minute goes in, 5,000 gallons a minute comes out. But in terms of speed, the water is going from 50 miles an hour down to I don't know, a mile an hour, a walking pace. What happens with the sludge?
Pump it out to the sludge tanks.
Got sludge pumps, and then a sludge tank. And then Hill Services takes that out to the landfill, right? That is not normal operation. I can't believe you guys just nodded when I said that.
Filter press.
No, filter.
Goes to the filter press. All right.
But they do take it out there.
It does happen that way. It's not how it's supposed to happen. But yes.
I really just thought that's where you were gonna stop it.
So then we pump sludge from the sludge tank into the filter press, and you fill it up, pulls the sludge tank down, the water comes out, goes to the drain, and all the sludge gets caught in there, and then we blow dry it, and then you open up the plates and it falls down like dumpster in the mud. And then Boral comes and takes the dumpster out to the landfill.
We add chemicals also.
We add chemicals.
Collagen, polymer, actually.
Polymer and coag goes into
Reaction. Polymer goes right into that first
the
track.
top.
Coagulant, polymer, and more hypo.
Polymer actually goes, right in that chamber. That line does, right into the clarifier.
Right to the rabbit mixer.
Oh. You're saying polymer doesn't go there?
Nope.
There's 3 fucking pipes there.
Yeah.
I'm taking your word for this, Lance. I'm gonna have to walk it out later.
Yeah.
You might be teaching me something today.
That actually goes in right there.
All right.
Oh, yeah, because the hypo and the coagulant is offset of the clarifiers. It's down there on the ground floor. On the ground level.
Right. No. There's 3 taps down here at the ground level, and I thought all 3 chemicals went in there, and now I'm being told that the polymer is going up directly into the rapid mixer, and I'm gonna have to look at that. And then I'm gonna figure out what that other 3rd tap is, because I know that pipe's there.
If you look at the cable tray coming up.
Yeah.
If you go to the rapid mixer and look off the back, look at the cable tray coming up and you can see the polymer line coming in and going out inside.
All right. So we already said coagulant is a snot, and it makes the dirt and mud in the river stick together and make clumps. And then the hypo is to kill growies, to prevent biological fouling. And when we don't use enough hypo, you'll see these plates get freaking covered with moss and algae and stuff up there. And then polymer, what's the purpose of that?
It makes it flocculate, makes it drop,
In the droplets.
makes the
clumpies clump.
clumps stick.
It makes the clumpies clumpier. So the polymer helps the coagulant clumps stick to each other. So you can only get so much mud around a coagulant clump, and then the polymer makes those clumps stick together and make bigger clumps. All right, then we go through the turbidity meter. What's turbidity mean?
Applied to the water is the same thing as opacity.
It's very similar to opacity. It's still involved. You got the water. You shine a light through it, With opacity, you're measuring how much light doesn't make it through. With the turbidity, you're measuring like 90 degrees off how much light got reflected sideways from it. But it's the same thing. You're measuring clouding. It's how much stuff is floating your way, and you're using light to do it. And then this is going to coolant tower. This is also going to where?
Clearwater.
Clearwell.
Bravo doesn't go to the coolant tower, right?
Okay,
My bad.
they both go to the coolant tower.
Bravo's on.
Bravo only is the only one that goes to the Clearwell.
Alpha's dedicated just to cool tower because we pump copon
Copon into
into
the
alpha and clarifier.
That is correct.
So you eliminate basically if you try to run that into your dealer, you just plug all your filter stuff out there basically. I mean, it would work, but you'd be constantly cleaning.
Yeah, you wouldn't get near as long on the multimedia filters. All right. So we've got 2 Clearwell pumps. They're going to the multimedia filters. When we say multimedia filter, what do we mean? What's it like inside it? Why is it?
A polisher?
It is not like a polisher.
Different course or sizes, sand, gravel.
Yeah,
I can't-
Yeah, so I think aggregate, something like that is what they like to use for thermal. So it's got 3 layers in it, and as the water flows through, the first layer catches the bigger stuff, and then you got a layer that's finer. So the stuff that made it through that gets to that, and then the stuff that made it through that gets to the next. So each layer has a chance of catching a smaller level of grit.
So usually you have like what they call green sand,
Anthracite? No, that's a type of coal. I'm making up words.
It's kind of like a coal. It's a charcoal type base. It's like, then you got gravel at the very bottom. So basically, it's like a filter bed. Is all it is. Packing, something like that.
So you could do all this just by having the finest level of thing. You could just fill the whole thing up with sand. But what would happen was that you, instead of having 3 layers where it's doing it, it'll do all its business in 1 layer, and then it would get clogged up real fast, and you'd be backwashing it all the time. So when we, all right. So as the layers get dirty, then the differential pressure goes up, and at 10 psi. You gotta take it out and backwash it, or you do it on hours most of the time, don't you?
They're doing it on hours. I mean, used to, like I said, we done it at 10 psi. Now they're doing it every 24 hours. But I mean, I still do it by DP.
If it gets up to 10 psi, then you should go ahead and do it. And I think 10 is the alarm. So if you get a DP alarm on it, you should go ahead and take it out of service and backwash it, no matter what the hours are.
If it gets around 8, 9, I do it regardless. If it's got 16 or whatever. But if it's up around that, I go ahead and backwash it.
This is going into the service water tank. And then coming off the service water tank, you've got the backwash pumps. And so when you take one out of service, then it takes water out of the service tank, flows it backwards across the sand and the aggregate and the gravel, and it knocks that stuff loose and sends it down the drain. makes the clear well pumps start and stop?
Surface water tank level,
That is correct. Surface water tank level. You know the range?
like 30, 35, 8, and
Kicks on at 35.5, and when's it kick off?
36, 8.
36.5. I don't know why you think it's 0.3 higher on both of them than I do. And then how full is full?
37,
37.3.
8. I was just-
It will never ever show 37.4. It will get up to 37.3 and then start putting however much you're putting through these multi-meal filters on the ground. How much is that? Is that what, 600 gallons a minute each? This is a number that you can actually change. You can type in whatever you want there. But in general, we want to keep it at whatever the hell the chemists left it at. In part because we don't turn over so good with them because they don't turn over at the same time. So if we go changing shit, it gets lost. And in part because there is a tote that is pumping. Hang on, should leave. Color change. There is a tote that takes water off the surface water pumps and transports from that tote to the clear well. And the amount, this does not look at this 600 gallons a minute. This is just on or off. So if you go tweaking these so you're not getting 600 gallons a minute, then you're throwing off how much of the chemical they're using. Not the end of the world, but it's not as great as it should be.
What is the chemical?
Sorry.
It is supposed to help.
Like somewhere.
All right, nobody knows.
What's up, Mike?
Water. I don't know. It's something the kill tree told them they need help. I guess we need Clark still. I don't know. I changed so much stuff out there all the time. I tell them about it. What new chemicals they're putting in and what we're doing.
All right. So we come off the surface water tanks and we go to the surface water pumps. And the surface water pump has a pressure control pump, pressure control valve, which is effectively a recirc valve, which goes back out to the tank. So this guy is what's maintaining that 120 psi, which I think is actually slightly higher right at the pumps, right? It's like 135. Whatever. All right.
Yeah,
So-
the pressure on the pressure gauge?
Yeah.
Yeah, about 135.
Okay. So when we start using a bunch of surface water somewhere, then the pressure goes down. You open up a valve somewhere else, so this pressure goes down, and then this valve, the recirc valve, pinches off to drive that pressure back up to where it was. And at a certain point, the recirc valve's shut all the way. You don't have any more control. The pump's just doing all it can. Check valve. And there's two of these setups. And there's also two surface water tanks. And you can arrange the valves in such a way that you're only drawing off one surface tank and recircling back to it. And that the other surface water tank could be completely drained. I don't remember the exact number, but somewhere around 29.5, somewhere in the 29s, then you lose your surface water pump permit.
Yeah, fire water.
So This is a 550,000 gallon tank. And the top 100,000 is available for surface water, and the bottom is reserved for fire water. And the way they reserved it is that by actually pumping in the surface water pump suction, it is piped in 25 feet up. And you got the main electric fire pump. And then coming off of the Bravo tank, you've got the main diesel fire pump. And then in the room with the electric fire pump, you've got jockey pump. Because it is way easier to kick on and off that little guy than it is to start and stop this 4160 volt pump. And the two tanks are cross-connected on the suction side of the fire pumps. Keep going. All right. So, what all do we use surface water for? Slaking water. Say again? FGD tank.
Can use it for drag chain, basically.
So the drag chain, you actually do use it all the time in the drag chain
Right.
because it's got little spray valves on the chain that are supposed to keep the sprockets from getting clogged, as well as emergency makeup for the bottom ash drag chain. That FGD tank is the lion's share of the water we're using. Because you're using 50 gallons a minute through 6 atomizers, so that's 300 plus gallons a minute. The slaking water is like in the 150 to 200 gallons a minute kind of ballpark, and it kicks on and off depending on tank level and how much slurry we're using. There's one more big user.
Also free still water.
Okay, we have sealed water. Out of the river water. We got sealed water at the circ water pumps. We got sealed water at sump 3. There's probably some other little
Slurry
sumps.
pump.
Second,
Slurry
slurry
pump.
pump. So-
FGD,
Hang on. There is a high pressure surface water pump in the turbine building. It is got considerably less volumes, considerably less gallons a minute that can go through it than the big pump, but it is kicking up from 120 pounds to 180 pounds, and that is what provides enough pressure to the slurry pump and the FGD pump seal water. And as well as the hose taps all the way up the boiler. Like you wouldn't have 120 pounds, I don't know what the water pressure would be like when you get 200 feet up. But it wouldn't be like it is, it wouldn't be what you need to wash down to.
Oh, still about that.
Did we hit the last big one?
It's something you probably you hardly ever have to freaking think about. But it uses a lot of water. Quenching water. For
Oh, the cannons.
no, Water cannons comes off the service water header. That does not use a lot of water, but that is totally. That is
Blow down thing.
correct. Quenching water for the blowdown tank. So you have 600 degree water that is coming off of the boiler, and it's flashing the steam and it's cooling off, and then it goes down to the blowdown tank, and it's basically 210 degrees by the time it's in there. And then we add surface water to cool it down to 140 degrees before we pump it back to the pump tower. All right. That blowdown tank and that FGD tank, both of those guys fail open on a loss of air. So that's good to know. Because it's a mess, especially if it's freaking freezing outside. Alright. The other thing we do with surface water is we make demon water. So after the surface water pumps on the way to making demon water, where do we go?
Mixed bed? Is it?
Mixed bed is the last step.
Oh,
Softeners.
Softeners. Zeolite softeners. What does a softener do?
Takes the metals out of the water.
Yes. So it removes the hardness, and the hardness is dissolved metals. Science. So we've got things like magnesium and calcium and iron ions, and we're taking those out, and that we are replacing them with sodium. What's next?
Cartridge.
Alright. Ooh, those should be the same size.
I just like how you're trying to save space.
Yeah, it's getting tight in it. I don't want to flip over. So we got 5 micron cartridge filters. And only one of them's in service. And chemists are monitoring the DP on them. And then where do we go?
Or
Permeates.
You were way ahead of yourself, bud. Somebody said RO pumps?
yes.
RO pumps is the correct answer.
We also inject a chemical in there too.
Yes. Is that the outlet side?
On the cartridge, the disulfide.
Terry, what is the purpose of bisulfite?
To remove the offset the sodium or what the
Stop. Josh! Mark?
No,
Lance?
you won't remove all your hypo, anything out of there.
Bisulfite kills the hypo. So bisulfite bonds together with hypochlorite and makes it inert, so it quits interacting with things.
all right, because the hypo will mess up the filters.
The RO membranes, they wear out faster when they're exposed to hypo. They get brittle. I use quotes a lot when I'm talking about things I don't really understand, that I'm taking other people's words for it. Alright, that same tap, the chemists will once a day disconnect the line from the bisulfite and hook up what's called a biocide Bio meaning life, so it does the same thing as the hypo. It kills the growies, because if you don't do something to kill the growies, then you get biological fouling on your membranes, and it doesn't matter that you protected from hypo, you lost them to algae. For this reason, the chemists like to turn off the ROs at night so that they know that in the morning they'll have room in the demon tank to run them, so that they can hook up their biocide and run it for an hour before they go back to their normal bisulfite process. All right. So we go from the RO pump to the RO membranes. RO stands for reverse osmosis. What is osmosis? Nobody got nothing for me?
I know what it is. I just can't think of it right there. I go watch Osmosis Jones. It's got to be similar.
All right, so you have a membrane, and usually you learn this in like a 9th grade biology class, and they're talking about cells. And the membrane will let water through, but it won't let anything else through. And that way, that way the cell can absorb water without giving up everything that's inside. And so the natural tendency is for the water to flow in and dilute out the other side that has the contaminants, has stuff in it. That's osmosis. Reverse osmosis is pushing the other way through the membrane. So you're trying to push across the membrane and keep the dirt on one side and get the clean stuff out on the other. So we have a first pass and a second pass. So you go in. It looks like a long cylinder, right? But what you actually have in there is the membrane is like a sheet that is spiral wound. And so there is one side of the sheet and the other side of the sheet. And then all those come together in a header where all the clean side are on one side and all the dirty side are on the other. And on the outside edge, there's a tap where the stuff that was not clean gets pushed through. And then we say, well, let's try again. And we stick it through another set. And the stuff that comes out there, this stuff goes to a drain. And then the clean stuff comes together. And then we go to a second pass. I need a bigger whiteboard. We're going to learn to draw small. So there is another RO pump on the skid. And it goes, the clean stuff comes out, and the dirty stuff comes and it makes the second pass. And that clean stuff comes out, and that's the stuff that is good enough. And the dirty stuff here is still cleaner than the stuff over here. No, hold on. Still cleaner than the stuff we were getting from the softeners. So it goes back and makes another pass. And then this clean stuff goes to the permeate tank. So permeate is what went through the semi-permeable membrane. And then we got pumps coming off of it. And then we got mixed beds. And coming out of the mixed beds, we go to the demon tank. Even though you can't tell, this demon tank is the same size as one of those surface water tanks. I know my drawing makes it look small. All right. Mixed beds. How do they work? What do they do?
Yes, they're same, kind of like the polishers.
They look just like the polishers. Got anything to add besides that?
They're working like the polishers. They're taking away something and adding something to it.
Right, yes. Ion exchange. So we are taking out sodium and chloride, and we're putting in hydronium and hydroxide. And the fancy part here is that the H plus for the hydronium and the OH negative for the hydroxide, those come together and they make H2O. So the stuff that you're putting in is becoming water.
Pure water.
So when we do a regen, we're getting the H plus from acid, sulfuric acid, and we're getting the OH from the caustic. So the same way, we had 3 levels here that let you run longer without. We kind of didn't need any of this. We could have just gone straight to a mixed bed. But you wouldn't get any kind of life out of it. You'd be regenerating them all the time. And these things run for like 1 million gallons of throughput. At 150 gallons a minute, they last a good long time. I said 150 gallons a minute. That's what they're rated for. That's not what we actually run them at. I want to say 135 or something.
Yeah, 100, yeah.
And that limit is based on the RO membrane, not like in cold water. So when the surface water tank gets down to like 35 gallons a minute, they really can't do the 150 gallons a minute that they're rated for and promised. And so rather than trying to remember to tweak with it all the time, they said, 135 is good enough.
Is the regen on those as complicated as the regen on the softeners
No.
downstairs? Does it,
So it's all done within the one vessel.
okay.
So no, it's not as complicated because of that. But there is something similar where you have 2 different kinds of beads. You got the H plus beads and the OH negative beads, cation and anion beads,
Yeah.
right?
You got the same, you got the same resin, you got the polisher. You got
So you-
cation and anion.
So then when you backwash it and then you fluff it, and when you fluff it, then the heavier beads want to end up on the bottom and the lighter beads want to end up on the top, and that's how you end up separating it. And then we put the sulfuric acid on the heavier beads, and we put the caustic on the lighter beads. I'm only 90% sure that's true. That might be backwards. But the point is, the chemicals, one chemical is heavier than the other, and they designed it so the beads that go with that chemical is heavier than the other, so that this can all be done inside one vessel where it floats on top. The acid and the caustic, they interact, but they don't get stirred up. It's like oil and vinegar. All right.
Like I said, we used to regen those, but it got where, Chemtech, this is ours. But they didn't want nothing to do with polishers. So you got to do all that separation, all that. It's a lot more,
I've seen Flipper do it. That's why.
yeah, I mean,
So, with 90% of the stuff out here, all you're doing is hitting start.
Right.
So, and with our polisher regen, I mean, it's more complicated, but you hit start and you leave it alone for 18 hours. And then you come back and you have like 10 steps you actually monitor. That takes, 2 hours. And then it's in auto for another 10 hours after that while it's rinsing it.
Right.
You got two critical steps on polishing, basically. Separation,
Make sure
don't
it
leave it,
starts.
and chemical injection. Now the rest of it, that does that.
There's another place we use acid. We use acid for regening, and we used acid in the ROs. I think it's between the two skids.
Yeah.
Between the first and second pass.
Well, actually, you use caustic.
Am I backwards?
Yeah.
Alright, caustic. So caustic raises the pH. And there's something about this reverse osmosis process that makes the pH go down. And I don't understand it. I've asked the question in class with people that gave confident answers, but I did not understand what it was well enough to. So it's one of these things I'm going to put in quotes. Something in the process causes pH to go down, and we want to bring the pH back up. So we add caustic. And that might be it. Any questions? And scene.